Welcome to the second episode for electronic essay type questions. This question is from Diodes and it's a very simple question actually just for you to learn the flow of questions. So first 4 or 5 questions will be quite easy questions, but still go through with these questions. You will learn at least something new. You have to learn something from it, and we'll be getting to bit of difficult questions later. So go through with this question. First try the question and then later let's go through the video explanation. The diagram shows a voltage regulator circuit arranged by using Zener dial. Zener voltage is 15 volt. Find these values. Alright, I hope you have tried the question now. Let's get into the question now. This question, actually this is not that much of a difficult question, but still as a start actually let's go through with this question. So initially they are asking us to find initial current through RS resistor. This is the RS resistor. So current will flow through 2000 ohms resistor and it will go through this way, and even it can go through the Zener diode as well, right? I hope you know the theories about Zener diodes. Actually we use Zener diodes in reverse bias form in order to maintain constant potential difference across it, right? So knowing the theories, they are asking us to find the initial current through RS resistor. So in the data actually they are telling the Zener voltage is 15 volt. So the potential difference, if I grounded here, if it's 0 here, the potential here it will be 15 volt, right? So the remaining 15 volt will be absorbed by this 2000 ohms resistor. So the potential difference across RS resistor will be 15 volt. So let's apply V equals IR for this RS resistor. V is 15, so that divided by I, that is what we need to find, 2000, right? Then yes, I here equals 15 divided by 2000. So it's easier to multiply it in this way. Normally I'll multiply it by like this, multiplied by 5, multiplied by, because then I can get it to into 1000 terms, so it's easy to divide. So 5 into 15 is 75, divide by 10,000. So 10,000 means 10 to the power minus 4. So finally we can conclude it's 7.5 into 10 to the power minus 3, 7.5 milliamperes. So the current through RS resistor will be 7.5 milliamperes, right? Then they are asking us to find the current through RL resistor, this load resistor, right? Moving into, now we know the total current is 7.5 milliamperes. So current will get divided into two parts, this path and this path. So they are asking us to find the current through this path, right? Actually if I grounded here, if it's 0 here, the potential here will be 15. That means the potential difference across these two the terminals will be 15 volt, right? Then this diode will keep 0.7 volt. So the rest of the potential, yes, will be taken by this RL resistor. So the potential, point potential here, I can say it's 14.3. Right here it's 0. So let's apply V equals IR for RL resistor. V equals IR for RL resistor, it's V 14.3 I into R, 2860 ohms. So here I get I 14.3 divided by 2860, right? Actually getting the answer for this bit of a difficult, but if you keep closer look into this multiplied by 5, actually it's 14 point something or 143 we will be getting. So just try dividing it. Actually we are getting from this 0.05, right? That means it's 5 milliamperes, 5 to the power minus 3, right? So we have the second answer now. It's 5 milliamperes. First answer we got 7.5 milliamperes. Find the current through the Zener diode, right? The third one. Actually we can apply Kirchhoff law here, 7.5 milliamperes up to here, and through this path we will be getting 5 milliamperes. The remaining amount 2.5, yes, that will go through this 2.5 milliampere, that will go through this Zener diode. So it's 2.5 milliamperes. What is the reverse bias resistance of the Zener diode, right? To find that, reverse bias potential, right? So potential difference across this Zener diode is 15 for sure, right? The current through it, yes, we found it is 2.5 milliamperes. So what you can do is we can simply apply V equals IR for Zener diode. V equals IR for the Zener diode. V is 15. So we know 2.5 into 10 to the power minus 3, that into R. So we are getting R 15, 2.5 into 10 to the power minus 3. So for the simplification, I'll multiply this by 4 and this by 4. So then I can easily get a value of 10 here. See? So 4 into 2.5, 10. 10 into 10 to the power minus 3, that's just 10 to the power minus 2. 4 into 15, it's 60. So you can see it's 60. I write it here, 60 into 10 to the power minus 2. Yes, it's 6 ohms, right? So we have our fourth answer, 6 ohms, right? Find the power dissipation at the Zener diode, right? Finding power dissipation, you know what we have to do is power dissipation equals P equals IV, right? We know the current through it, it's 2.5 milliamperes, 10 to the power minus 3, V is 15, so 15 into 2.5, that is our power dissipation. So 2.5 into 15, we are getting 37.5 into 10 to the power minus 3 watts. So you can write it like 3.75 into 10 to the power minus 2 watts. That is the power dissipation of the Zener diode, right? This question actually, it is not that much of a difficult question, but still, just like an essay question, we have a flow. Initially we need to find first answer, and the second, third, fourth, fifth, likewise we have to move. So first, initially you should practice small essay type questions. So this is the start for that. So just go through with these questions, and slowly we can move into the difficult type of questions, right?